Good evening, everyone. We are starting in 2 minutes for yet another webinar and one of the major concept of absolute value. And last week, I did a webinar on inequalities, which is uploaded. So I request the same that, you have to go through this webinar video again so that you could have the understanding of concepts in deep, and then you could apply those concepts to solve various questions across. So if you are looking to the old webinars, especially for the inequalities, you will definitely get a hold of those. Similarly, it goes to absolute value because it's not a difficult topic, but it's a very tricky because it's all about the distance, it's all about the range, and inequalities adding up to the same makes it more challenging. And that is what we all will discuss about it. So I welcome everyone on behalf of Math Revolution and giving us this opportunity to come with the lovely webinars and the unique approaches. So the agenda for today is talking about Math Revolution along with the GMAT math overview. And then I'll be definitely talking about the main webinar topic, which is absolute value. All those key concepts would be covered, which is required and must to know so that you could solve a DS and a PS question. Application of variable approach will be the key highlights today to solve the DS based absolute value questions. And then one question that I always ask, but I'm not getting much of the emails from you people, that what you're thinking about the conventional approaches versus math revolution approach. So, I mean, like, I don't doubt, but I'm a bit, you know, in dilemma whether are you following the YouTube videos or not, or are you applying the variable approach? Are you looking at those? If yes, then do write us on to our email. So going ahead with this, so we were established in 2001 in South Korea, having trained almost 41 plus thousand students, out of which 90% of students, or 90 plus percent of students have scored 49 out of 51, which is a dreamy score for everyone, Q49. And we are majorly getting a site visits of from almost 200 countries, and we have all in total members from 130 plus countries. Math Revolution website was launched in 2015 in the month of October, and we live up with the same goal that a GMAT test taker live with, Q49, 50, 51, or at least 47, because the possible combinations of Q always goes with verbal, and therein where the consolidated or the combined score is required for your application to pass through. So GMAT math score, how do we define Q50, 51 is simple. Variable approach for a DS plus IV approach for the PS, that is equals to Q49 above. Talking about the person who has given us this opportunity to crack DS with this unique approach is Max Lee, who is the founder and CEO. Having done with the master's degree, has taken GMAT almost 27 times, is still updating and working a lot every day and night on the questions and the question stem on the formats, and upcoming with a lot of new techniques to solve the questions also. Almost solved 100,000 questions, and he is the one who is behind the world's first variable approach. These are the major characteristics of Math Revolution. You'll always see us talking about our uniqueness, that is IV and variable approach. We always tend to make our content updated every time so that it can, even a non-math background student can relate it very easily and finds it easy to understand the concept, learn those concepts, and then progress over the learning path. Quickness is one, because timing is the major concern that I have been exposed to while talking to a lot of people over the call these days into one-on-one free consultation call. So major challenge is not only about the accuracy, major challenge is not about the score upgrading, it's always about the time as well. So most of the student often face issues with the timing part, and when the time is compromised, then accuracy may compromise at the same time. So these are the four characteristics that our solution, our approach is always worked through. And the basic strategy for 50-51, as I've always told you in the previous webinars also, That conventional approach doesn't guarantee that everyone would be able to score 50-51. Few may able to with their existing knowledge on the math part. But again, if you are not good with your math skills, or if you have left math during your high school and then you have never got a chance to apply it anywhere, if you're picking it after long years, then I would say it's the right time to pick the quick approaches rather than going or falling for conventional approach and after a month's time falling for a time foundation. So variable approach plus IV approach plus all the concepts that you make throughout your learning curve will definitely give most of you 50-51 is a score. Let's start with the webinar for today, which says absolute value. This is quite interesting webinar, to be honest, because this is one of the webinar which is close to my heart, because this is a bit challenging, tricky, looking at the distance, looking at options and getting confused with why negative is not possible, why negative becomes positive. So understanding the definition of absolute value is all about, it's a distance between the number and the zero. So if you're talking about distance, which is a scalar quantity, distance can never ever be negative. This is the first point. Second, you either take it from the left side or the right side, you are able to get the distance. So the concern is distance can never be positive. No, distance can never ever be negative. It has to be either a positive or equal to zero, or and secondly, it has to be considered from both the sides. So therein where we always keep this particular point in our mind. Modulus x or mod of x is way we denote the absolute notations, and mod of x has to be greater than equals to zero. So mod x can never ever be negative. This is what you mean. You can put the negative values into mod to make them positive, but mod x will never give you a negative value. Always remember this. Now this is wherein the example says the absolute value of -2. So how far is -2 on the number line from 0? It is 2 units. So the distance is 2, and that is what the absolute value of the particular -2 is proclaimed. So that is what it is 2. It is greater than 0. So it's not negative at all. So for -5, it will be 5, -3, it will be 3. So, this is wherein we are not getting anywhere the negative values. This is one of the most important property and most helpful relation throughout the absolute value application, I'll say. The nth root and how does the nth root and absolute values are equated to each other. So if there is a number a and I'm taking the nth root of that number, and now that particular number is also raised to a power n, then I have to just see one thing, whether that power n is even or odd. And that can give me a lot of things, like if the nth root, if I'm taking the nth root and the power is same, if n is odd, I'll get it as a. But if n is even, I'll get it as mod a. Now, make sure that you remember this trick and tip. It is pretty direct and it would be applied in almost all the questions today. So, if you're taking an nth root and you're raising a power, if your n is odd, it becomes a, but if your n is even, it becomes mod a. So in this particular example, where my -2 is under cube root and it's been raised to power 3, 3 being an odd power, my resultant would be -2. But if it was 2 squared into the square root, it will retrieve me mod of 2, which is 2. So this is one of the application format, and this is one of the key rule I would say that you should always remember. And now let's see a question, how will you apply on this? So we have this particular PS question which says the square root of 2 square, then you have a square root of -2 square, then you have a cube root of -27. The most easiest way to solve this question is to remember what we learned right now. If you have an nth root of a number a, which is raised to a power n, just see whether n is odd or even. If it is an odd, take the number into mod. If it is a if it is a odd, directly take that number. If it is a even, then take the number into an odd. So let's try this. A square root of 2 is square. Power is even. So it becomes mod of 2, which is 2. Second part is square root of minus 2 squared. Your power is again even, so that becomes mod of minus 2. And negative of minus 2, doesn't matter it's a negative or positive, absolute value will always return the positive value, so that becomes 2. And the third part is cube root of minus 27. That is written as minus 3 cube. So now the power is odd. So I'll directly take that number as minus 3. So I cannot take minus 27 directly because I have to express that in terms of cube because I've been raising it to cube root. So that becomes minus 3. So I guess now the question has been very easy. It's 2 plus 2 minus 3, that becomes 1, and my job is done. This should not even take 20 seconds to solve. So let's go ahead with the next question. If n is an odd number, so they've already given that n is an odd number, then what is the value of nth root of a times nth root of b, and the product is again raised to a power n. Now when we know that n is an odd number, then root sign will disappear. So if you're multiplying exponent through the brackets, so the power that we have on the side, which is n, it gets distributed to both a and b. So it becomes n root of a to the power n times nth root of b to the power n. And n is an odd number, so we'll just have a and b left out. So that should be ab, and our answer is a. That's it. Because they've already told it's an odd number, so I'll be just left out with the number itself. If n is odd, if the power is odd, then I just have that number left out. So AB is my answer. Let's go with first property of absolute value. If you wish to take the pictures, you can definitely take it, but I would recommend just to pay attention right now what we're discussing here. You can often go back to these videos, take the proper notes onto your papers, and then learn it. So first property of absolute value, this is what we have learned. If n is even, we get it as mod a. Mod a would be a if a is greater than 0. Mod a would be 0 if a is less than 0, a equals to 0. Mod of a would be equals to negative a if a is less than 0. This is the most confusing part because we always have that statement ready that modulus cannot be a negative. Modulus cannot give me a negative value. So now understand this mod a is not equals to minus a. Understand the part that is written just next to it. A is less than 0. So suppose if my modulus of x is giving me minus 2, that means that particular value has to be less than 0. So what happens is if I put that a equals to minus 2, minus of minus 2 will make it 2. So my modulus is not giving me a negative value. Always remember this. It has to be a positive. So in the first case, it was always positive. So it has to be greater than 0. When your modulus A will give you a positive value, when A is greater than 0. When a modulus A can give you 0 value, when it is equal A is 0. And modulus A can never ever give you the negative value. But what if there is a negative value, minus 2, minus 3, what happens then? So to make it positive, we need to consider it as minus of that value. So minus value gives me the positive value. So always remember this so that you never ever get confused with this. Let's try this question. If P is not equals to 0, P over modulus of P is equal to what? And now these are the multiple choice questions again, like we could have more than one options also. So if P is not equals to 0 and P over modulus P is something that we are talking about, there's no root involved into it. So how do we solve this now? So now P is positive, then P is greater than 0. So mod of p would be definitely the p. So we're considering if p is positive. See, p cannot be equals to 0, so p can only be negative or a positive. So if p is positive, then p remains positive in the numerator, and the modulus of positive value will be always a positive. So your denominator is also p. So that gives me 1. So if it is 2, modulus of 2 is also 2. So 2 over 2 is equals to 1. So my option number third is automatically true. Now, if I have to consider p as a negative, p is less than 0. So numerator becomes negative, but the absolute value of negative p would again be a positive. So that gives me -1. So option number 1 happens to be true again. So my first and third option, it cannot be equals to 0 because p is not equals to 0. So only first and third condition is applied, which is E. Now in this sort of question, which says if x minus y is less than y, so if the subtraction of two numbers is less than y, you never know what y is. Is that a, what number is that y? So you cannot still say about x and y, yes. But again, that is a condition given that if x minus y is less than y, then which of the following is equal to that algebraic expression that has been written? Now, if you see here, it's a square, there is a root sign. So we again recall our concept, nth root of a to the power n, it becomes mod a if n is even. Mod a would be equals to a if a is greater than 0, equals to 0 if a is 0, minus a if a is less than 0. So if you see this particular expression written into the square root, which is x squared minus 4xy plus 4y squared, the best way to solve right now this particular quadratic expression is to factorize. So x squared minus 4xy plus 4y squared definitely gives me x minus 2y whole squared. That's a basic algebraic expression that we know how to solve. So now x minus 2y squared, and we already have a square root, so we are just left out with x minus 2y in the numerator part. So you could also say that is square root of x minus 2y whole square. Since n is even, I'll be left out with mod of x minus 2y. Now mod of x minus 2y will give me the value minus of x minus 2y, because it's, now why is that so? Because if you see the expression x minus y is less than y, if we subtract y from both the sides, it becomes x minus 2y is less than 0, which indicates that x minus 2y is negative. So mod of x minus 2y will give me the value negative of x minus 2y. So my numerator is ready, which is minus of x minus 2y divided by the same factor x minus 2y will give me -1. All right, let's solve this question. If mod of, there are a couple of numbers with the operation plus and minus, is been equated to m times of square root 2 plus n times of square root 3, what is the value of m plus n? Now, one basic smart idea that we know here to find the value of m and n, which has a coefficient of square root 2 and square root 3 respectively, can only be possible if I could write the left hand side in the same format so that I can compare the coefficient. And that is the only possible way I can solve this question in fraction of seconds, or maybe a minute time. So I'll quickly not waste our time. We are dealing with this radical signs here. We have our this first property ready in our mind. We directly go to the left hand side and start solving. But before that, you should always remember that if there happens to be a square root of a square b, so far we were dealing with a single number a. Now what happens if there happens to be a factors or multiples like 2 times 3, 2 times 3 squared? So in that scenario, if this is a case therein where we come in the radical sign, a square root of a square b, how do we deal with? So we deal it like a squared is already been squared, so that gives me mod a because n is even, and b remains with the square root of b. So applying the same, let's solve the LHS first, the left hand side. So we have, so we don't have to simplify its square root of 2, that is okay. We don't have to simplify square root of 3, that is also okay. Let's simplify square root of 8, which can be easily written into the format 2 is cube, but we are dealing with a square root, so it's much better for us to write it into terms of a square. So we could get it as 4 times 2, and 4 is 2 squared, so we can write it as 2 squared times 2. Similarly, for 12, we can write it as 2 squared times 3, which ultimately gives me minus of a square root 2 plus a square root 3 plus 2 times of a square root 2, because this is an even is power, so this becomes only 2, and square root of 2 is left out. Similarly, for minus square root of 2 square dot 3, it is minus 2 root 3. Adding the like terms gives me minus square root 2 plus 2 root 2, that is root 2. And square root of 3 minus 2 square root of 3 gives me minus square root of 3. Now, one important part here is we know that square root of 3 is greater than square root of 2. But in a modulus, we are doing a square root of 2 minus a square root of 3. That means that should give me a negative value. So that means that is less than 0. So my square root of 2 minus a square root of 3 is less than 0. That means the value that's going to come out of this square absolute mod would be negative of a square root of 2 minus a square root of 3. That makes it, on distributing this negative sign inside the bracket, it makes it a square root of 3 minus a square root of 2, or minus a square root of 2 plus a square root of 3. Now comparing this with the given format, which is m square root 2 plus n square root 3, m becomes minus 1 and n becomes 1. And there should not be any hassles adding up minus 1 plus 1 to get a 0. So the correct answer for this question is not E, but it is C. Let's go with another question which says 0 is greater than B, which is greater than A. That means B and A are negatives. What is the value of, there's a cube root radical plus a square root radical, and then we have a square root of A square plus cube root of B cube. The same property is something which we are applying right now. N is even. And what happens when there is an nth root and n is odd or n is even? So let's do this. The first radical part, cube root of a minus b 3, n is odd, gives me a minus b. Job done. Go on to the second part. 2, it is even. So a minus b, this is even, but the concern is we are not dealing only with a or a b. A is less than b, because it says 0 is greater than b, b is greater than a. So a is less than b. That means a minus b should be less than 0. So that automatically makes one thing clear, that mod of a minus b will give me a negative value for a minus b, and hence it would be reversed to get me b minus a. So this step is the most important one, that you should know whether that absolute value is giving me the negative for a minus b or it's a positive a minus b. The third part says the square root of a square, so that is mod a, but again a is negative, so that would be minus a. Cube root of b cube, so that would be b. So adding up all, it says a minus b plus b minus a plus b. I'm left out after cancelling the positives and negatives, will be left out with minus a plus b, which is nothing but b minus a, and your option is B. Your correct answer goes as B. Now, if this approach is there on the screen, definitely we are up to solve a DS question. So if there is, I'm just revising this for if there is someone new who has not been exposed to variable approach. So for us, the question, the given, it is called as original condition. So many a times we modify it, and in any inequalities and absolute value, there are higher chances that if you modify the equations or the expressions, you will definitely clearly get the answers in quick amount of time, and it would be easier for you to save time for other questions. So modify and recheck the condition. The original condition means the question. So check out the number of variables involved into it: a, b, c, so 3 variables; x, y, so 2 variables; n, so 1 variable. Or if there any equation like x plus y equals to 20, so that becomes the equation and 2 variables. And then we need to check if there are 3 variables and 1 equation, I still need 2 more equation to solve. So this 2 equation can come from both the statement number 1 and 2. So those are called as conditions. Condition number 1 and condition number 2. So depending upon the matching up of variables and equations, we could answer whether the answer would be C or E, or do I need to mark A, B, or D. So let's try solving this question for DS. If x is less than 0, that means it's negative. Is mod of x plus mod of x minus 1 is less than 3? Now their absolute value is there, but it's again with inequality. And the two conditions here are x is greater than minus 1 and x is greater than minus 2. We need to basically follow the three rule. Mod of a equals to a is greater than 0. Mod of a equals to 0, a is equals to 0. Mod of a equals to negative a is less than 0. Now, if you see the approach here, let's modify this particular question stem or the original condition. As I said, in inequalities and absolute value, you always modify a lot. So if x is less than 0, x and x minus 1 has to be negative. So mod of x would be negative x, and mod of x minus 1 would be negative of x minus 1, which is 1 minus x. So question is asking whether mod of x plus x minus 1 is less than 3. That means whether minus x plus 1 minus x is less than 3, which becomes minus 2x is less than 2. If I multiply both the sides by minus or divide both the sides by minus 2, the inequality is flipped and it becomes x is greater than minus 1. So my question is just one. Is x greater than minus 1? That's it. And what is my first condition here? X is greater than minus 1. I'll get yes. That's it. But my condition number 2 says x is greater than minus 2. So for minus 1.5, the expression doesn't hold. But for minus 0.5, expression does hold. So you can quickly check, and they have nowhere mentioned that x is an integer. So always pay attention to such words. So if you're getting yes and a no, that's not a unique solution according to common mistake type 1. This kind of jargons, common mistake type 1, common mistake type 2, common CMT 3A, 4A, 4B. This is all available into various lessons across CDE on mathrevolution.com website. That's a free resource. You can sign up for 7 days and learn through those lessons. Going ahead with it, the answer goes as A. Now let's understand the second property of absolute value. If A happens to be less than equals to modulus A, or minus A happens to be less than equals to modulus A, this holds for all the values of A. So for all the values of A would be less than equals to mod A, or minus A would be less than equals to its absolute value. Now, this is not that tricky to know or to understand, but how to apply and where to apply is the major concern. Now, this question says if R is greater than 0, that means R is positive. Okay. Mod of R is greater than mod of S. That is also said. Then which of the following must be true? It's not could be true. So please pay attention to must and could. So now see, the first observation that we have here is if A is less than equals to mod of A, or minus A is less than equals to mod of A, then we know that it holds for all the value of A. Second observation, if you remember in inequality, the first property that we learned, if A is greater than B and B is greater than C, then A has to be greater than C. So we break up. And the third observation is if X is greater than 0, then modulus of X would be equals to X. So now how to apply this particular property? Let's see the first observation, which says R is greater than 0. If R is greater than 0, then modulus of R will become R. And now modulus of R is already greater than modulus of S. And modulus of S will be definitely greater than equals to S. It can be greater than or it can be equal to also. So if we combine this inequality, we get R is greater than S, which is true. So the first option is true. If we go with the option number 2, which says R plus S is greater than 0, we know that modulus of S would be greater than equal to negative S. Now we know that R is greater than mod of S, and modulus of S is greater than equals to negative S. That means R is greater than equal to negative of S. If we transfer the negative S to the left hand side, it becomes R plus S, which is greater than 0. So my second condition happens to be true. The third condition is a square, which is R square is greater than S square. We know that R is greater than modulus of S. If you square both sides are positive. That makes it R square is greater than S square. And modulus of S square is equals to S square. So this all possible conditions must be true. So that is first, second, and third. So answer goes as E. So, whenever you solve absolute value, there is always applicability of inequalities and the properties. So if you still struggle with the application of inequalities, you need to go back to the same video that we did last time in the webinar. Go through all the particular properties, approaches once again, and then come back to this. And you could definitely have the avail of both the webinars together. Let's have a DS question. Is A plus B greater than 0? They're directly asking yes or no. So is A plus B greater than 0? So there would be a relation between A, B. So we will be applying the absolute value property, the first observation, because we are dealing with absolute value. Definitely the second observation, because we're dealing with inequalities. And the third observation, because we're dealing with less than 0 condition also. So if we try modifying here, there's nothing much to modify. It directly asks is A plus B greater than 0. It could be A greater than minus B, nothing more than that. I'm not lending up to any particular condition as such. So I'll quickly go ahead and check the number of variables. In the original question, A plus B, I get 2 variables. And now I need 2 more equation to solve. So my answer should be C. If I'm saying that my answer should be C, I'll combine both the condition together rather than not, wasting my time into checking each condition separately. If I combine condition 1 and 2 together, it says B is less than 0 and A is less than modulus of B. So A is greater than modulus of B, which is equals to negative B, because B is less than 0. So indirectly, we want to say that A is greater than minus B, because see, modulus of B will give you minus B if B is less than 0. This is the third observation here. If X is less than 0, then its modulus will give you its negative value. If B is less than 0, then the modulus of B will give its negative value, which is minus B. A is already greater, so A has to be greater than minus B. If I arrange that minus b to the left hand side, it automatically becomes plus and it gets me a plus b is greater than 0. That is yes. So combining both the condition, C seems to be an answer, but now there is a major rule in the variable approach. This is something which I have been always talking, that the earlier phase of variable approach is pretty direct, but when it comes to key questions like integers, absolute values, inequalities, statistics, you need to be very much aware about common mistake types, CMT4A and B, which says that if C seems to be an answer, then consider A or B as an answer. Indirectly, it wants to say that it would look that C is directly answered even without a solving, and there will be a trap in it. So rather than going that way, we'll take the condition number one, which says A is greater than B. So it doesn't say A is greater than B, but it says A is greater than modulus of B. And we know that modulus of B would be greater than equals to minus of B. So indirectly A is greater than equals to A is greater than minus of B, which is A plus B 0, and that is a sufficient condition. But if it says B is less than 0, I could have multiple options to it. If I put A equals to 1 and B equals to minus 2, I'm getting it as minus 1, which is less than 0. But if I put A equals to 3, a bigger number, I'll get it as a positive. So either I could get their sum as less than 0, either I could get their sum as greater than 0. So I need a unique value according to CMT1. So it's not sufficient. So my answer goes as A. To master this, you need to log on to www.mathrevolution.com to understand what the traps are and how do we actually get out of marking C and we get to A as an answer. But these are the most time saving approaches, I'm telling it to you. You don't solve much, you just apply the logics and concept, and that is it. Let's go with the third property of absolute value. If A is less than mod A, now it is not equals to. If A is less than mod A, then A has to be less than 0. And if A is equals to mod A, then A has to be greater than equals to 0. So let's apply this. Is X greater than Y? Now see, we know that if A is less than the modulus A value, its own modulus, then that is only possible if it is less than 0, if it is a negative number. But if it is equals to modulus of A, then it is always possible when it is greater than or equals to 0. So right now there's nothing much to modify in the question because it says is X greater than Y. So I'll directly go on to step number 2 and 3 to check the number of variables, which says that I have two variables, X and Y. So I need a two equation to solve this particular question, and hence most likely answer seems to be C again. So I'll quickly combine both the condition. Let's see what it gives. The first condition says that y is less than modulus of y. It is only possible when y is less than 0. And if y is less than 0, and if x plus y has to be greater than 0, then x has to be greater than y. Because negative plus negative will always give me negative. So if you have one number already as a negative, and if you still need the sum to be positive, the other number has to be a positive number and a bigger number than the y. So x is greater than y. That is what we are getting here. So C seems to be an answer. But again, the trap is it's a key question. So we need to check the condition number 1 and condition number 2 separately. Condition number 1 says that y is less than modulus of y, but we don't have any relation of that particular y with x. So that is insufficient. That's not at all sufficient. Question Condition 2 says that x plus y is greater than 0. So if x is 2 and y is 1, it is still greater than 0. But if x is 1 and y is 2, that is still greater than 0, but now x is less than y. So with this particular condition number 2, again it is insufficient to say whether it is alone sufficient or not. So for me, the answer goes as C. Let's understand the fourth property of absolute value. So the third property was if A is less than modulus A, then A is less than 0. But if minus A is less than modulus A, then A has to be greater than 0. This third and fourth property, people, you have to go back to this video and check it out. Just make a note of it into your copy properly and then apply it. See, we know this happens, that if minus A is less than modulus A, then A has to be greater than 0. If I give you 15 minutes, you will easily get me that result. But it has to be there into your back of your mind always as direct as it is. Like, okay, it's minus A less than modulus A. Okay, fine. My A has to be greater than 0, because when it comes to the question application, you don't get much time to apply this. And then you take in consideration all the possible combination that will form, and that takes a lot of time. This question on DS says that is modulus of x plus x greater than 0? Is modulus of x plus x greater than 0? And then I have two equation attached to it. So if modulus of x plus x is greater than 0, that means my modulus of x has to be greater than minus x. And my modulus of x can be greater than minus x only when x is greater than 0. It's this property, fourth property. If A is negative, it is less than modulus of A if A is greater than 0. Because if A is less than 0, this inequality fails, because it's already negative on the left hand side. So minus A would always be less than its absolute value if you're taking A is negative. No, if you're taking A is positive. If you're taking A is negative, this fails. So for this particular question, which says mod of x plus x is greater than 0, if I move x to the right hand side, it becomes mod of x is greater than minus x, which is only possible when x is greater than 0. So my question is very simple: is x greater than 0? Condition number 1 says is x is equals to 1. It's sufficient because it is greater than 0. So again, a modification has worked for us. Condition number 2 says that x plus y is greater than y minus 2x. If we cancel out y from both the sides, we get x is greater than minus 2x. Or indirectly, 3x is greater than 0, or x is greater than 0. So over here, what you're getting is condition number 1 and condition number 2, the value for both is similar. Whenever condition number 1 and condition number 2 gives you similar values, that means D is the answer. In 95% cases, you could see this. So in most of the other questions, it has been noticed that there would be one direct value and another would be in terms of something, or one variable in terms of other. So you could solve the second part quickly to get to know, are you getting the same value which is there in the other statement? That is when we see that the value of condition 1 is equal to value of condition number 2, and your D becomes the answer. Let's talk about first frequent case of the absolute value. Now, this is something which majorly and frequently appears on the GMAT. If mod of A plus B is less than mod of A plus mod of B, then AB has to be less than 0. Vice versa, if the product of A and B is less than 0, you could say that the mod of their sum is less than mod of their individual sum, or sum of them individual mods. How do we get it? We can simply take that particular inequality which says mod of A plus B is less than mod of A plus mod of B, square both the sides. On the left hand side, we are dealing with the square part of modulus. We'll get a plus b whole square is less than mod of a plus mod of b. Mod of a square is a square. You can open it as a square plus b square plus 2 times ab is less than modulus of a square plus modulus of b square plus 2 times of modulus a modulus b. Now modulus of a square is nothing but it's a square. So we can cancel out the a square plus b square from both the sides. So we are left out with 2ab is less than 2 times of modulus ab. That means ab is less than modulus of ab. Now ab can only be less than modulus of ab when ab have a different sign. That means ab is less than 0. So product of a and b if happens to be less than 0. This was the first property that we learned. Let's try this question. Is mod of a plus b less than mod of a plus mod of b? So we know this case, that is, if mod of a plus b is less than mod of a plus mod of b, then ab has to be less than 0. That's the condition number 1. This is what we are exactly looking for. This has happened many a times, that there are too much direct questions, but we still not remember it, and we try putting in lot of, you know, values and possible cases, and we just, you know, waste a lot of time into it. So these approaches are, or quick approaches, are very useful. And if you could get a time, definitely the best thing would be to go through these videos as many as time you wish to. So condition number 1 here is satisfied. Condition number 2 says that a is greater than 0. Possible cases are there. If I consider b to be negative, the product would be less than 0. But if I consider b to be positive, then the product would be greater than 0. My a is 1 in both the case. So this is not unique, so answer is a. Let's say the second frequent case, which is equal to. So mod of a plus b is equal to mod of a plus a. In this case, your ab would be greater than equals to 0. So first one was less than. So your product was also getting ab is less than 0. Second one is equals to. So how do we apply this particular? This is the particular proof. How do we get it? It's again the same. We square both the sides. We cancel out a square plus b square. We are left out with 2 times of mod a, mod b equals to 2 times of mod ab. So at the end, ab is equals to mod of ab only when they have the same sign, or ab has to be equals to 0, or one of them has to be equals to 0. So this is a very common question that comes into GMAT. Is x, y, z is the product of 3 variable is greater than 0, and then you have equations like x, y, x, and y, z terms. Now, if in this particular question, if you see, we need to find whether x, y, z is greater than 0. We are dealing with 3 variables, x, y, z, and we don't have any equations here. So we have 3 variables. We need 3 equations. We could get 2 equations from mixing up both the condition number 1 and 2. I'm still short of 1 equation, so my answer should be E. When I feel like my answer is E, when I know that the most likely answer is E, I'll combine both the conditions 1 and 2 together, which says x plus y is equals to mod of x plus y, only possible when xy is greater than equals to 0. Condition number 2 says y plus z is equals to mod of y plus mod of z, only possible when yz is greater than equals to 0. Now understand this, xyz is equals to 1 if xyz is equals to 1. 1 times 1 times 1, that is 1 is greater than 0. So that is yes. But if x equals to y equals to z equals to minus 1, then you are getting it, the product as minus 1, which is less than 0. And your xy and yz product are still satisfied. So in that condition, you're not getting a unique yes or unique no. According to CMT1, condition combined are not sufficient. Answer goes as E, which ultimately we got when we did step number 2. So this is the beauty of variable approach. You get to know the most likely answer at the start of the question, and then it becomes very easy for you to complete it. Any amount of second or minute saved in a question or questions would definitely help you in other questions. So you would be able to maintain your accuracy, boost your accuracy and your time frames. Let's talk about the third frequent case. The first one was less than, the second one was equal to. Now this is the third one. If mod of a minus b has to be greater than 0, then its squared would be greater than 0. Or you could say, if modulus of a minus b is greater than 0 and the square of a minus b is greater than 0, then a can never ever be equals to b. Is a minus b greater than 0? This is what the question is asking, and we are given a equals to 0 and b is greater than 0. We know that a cannot be equals to b. None of our condition is saying the same. We cannot find whether a is not equal to b or not. So modification doesn't work here. We'll follow the second and the third step. We are given two variables. We need two equations. Answer should be C. Combine both the condition which says A is equals to 0, B is greater than 0. If B is greater than 0, then B is positive. If A is equals to 0, then A happens to be smaller than B. Then that means A minus B, if B is greater than 0, that means B is greater than A. So B is not equals to A. So you're ultimately getting whether your modulus of A minus B is greater than 0. Yes, it will be. So condition combined are sufficient. You again saved you a lot of time in this. You don't have to check an individual condition because you knew that C would be a most likely answer. Let's talk about the fourth frequent case of the absolute value, which says less than. So if your A minus B is less than equals to 0, or if there is the square of their subtraction is less than equals to 0, then A has to be equals to B. Now, how do you apply this particular logic? If it says A minus B is less than equals to 0, and there are two conditions to it. So mod of A minus B is less than equals to 0, or A minus B whole square is less than equals to 0, then A has to be equals to B. Our question is asking the same. So we need to find whether A is equals to B or not. So we are no more dealing with the absolute value or inequality. We know that if A minus B has to be less than equals to 0, that means has to be equals to B. So now we just need whether A is equals to B or not. So let's say condition number 2, which says AB is equals to 1. A and B are both positive integers. When they are positive integers, fractions are not allowed. If they're positive, then both of them are positive. So A and B product can be only equals to 1 if A is equals to 1 and B is equals to 1. That gives me A is equals to B. So my condition number 2 is automatically sufficient. Condition number 1 says that A times of A minus B is equals to B times of A minus B. We require a simple rearrangement into it. So we get it as A square minus AB, that's a distribution of A on the left hand side, equals to B times A minus B squared, that's a distribution of B on the right hand side. Rearranging everything on one side gets me A square minus 2AB plus B square is equals to 0, which is nothing but A minus B whole square equals to 0. If A minus B whole square is equals to 0, this is only possible when A is equals to B. So my individual conditions here are sufficient. This is a application of CMT4B. If you're getting A and B very easily, your answer should be D. 95% times it happens. Let's talk about the fifth frequent case. So we have done with the less than, we have done with equal to, we have done squaring equal to, we have taken the conceit case where A is not equals to B. We have taken the fourth case as A is equals to B. And the fifth case here is if squaring A and B separately and adding up gets me 0, or mod A plus mod B is equals to 0, or square root of A plus square root of B is equals to 0, or keeping one of them as a square and taking another as a mod is getting me 0, then A and A equals to B, yes, but that is all equals to 0. So now this is a PS question. When x minus 1 plus y plus 2x is equals to 0, then what is the value of x plus y? So now see, mod of x minus 1 is equals to 0. That means x minus 1 is equals to 0 and y plus 2x has to be equals to 0. So if x minus 1 happens to be equals to 0, x is 1, and y plus 2x is equals to 0. That means y becomes minus 2 times of x. X is already 1, so y becomes minus 2 times of 1, that is minus 2. X plus y, that is 1 plus of minus 2 gets me minus 1. Answer goes as B. Let's see what we have into the sixth frequent property. That is, if your modulus A is equals to modulus B, A can be equals to plus minus of B. Of course, yes, this is a very basic one, but very much applied. So if your mod of A is equals to mod of B, you can square both the sides, you will get A square equals to B square. If you bring in B square on the left hand side, it becomes A square minus B square equals to 0. If you factorize that, you get A minus B times A plus B equals to 0. If your A minus B is equals to 0, A is equals to B. If your A plus B is equals to 0, that means A is equals to minus B. And that is why we say A is equals to plus minus B. Very common question. How many values of integer x are there such that whole mod of x minus 6 minus 4 is equals to 4? Very common question. So now see, understand, if mod of A is equals to mod of B, then we know that A is equals to plus minus B. So first thing first we'll do is we'll remove the outer mod. So if we'll remove the outer mod, we'll left out with mod of x minus 6 minus 4 is equals to plus minus 4. The possible case happens is x minus 6 minus 4 is 4. So the first value that we get is mod of x minus 6 is equals to 8. And the second value would be mod of x minus 6. Now over here only we can solve two cases. If we know that x minus 6 will give you two values, plus 8 minus 8. Keeping plus 8, we get x equals to 14. Keeping minus 8, we get x equals to minus 2. So we have two values here, x is equals to 14 or minus 2. Taking the another case for the first part that we did, it becomes mod of x minus 6 minus 4 is equals to minus 4. So x minus 6, modulus of x minus 6 is equals to 0. If it is equals to 0, then x has to be equals to 6. There is only one case. So all in total, we have three possible values, 14, minus 2, and 6. Answer goes as C. Let's talk about the seventh frequent case. Absolute values are same as squares. Very important property. Mod of AB can be broken as mod A into mod B. If you're dividing mod of A over B, you can always divide mod A by mod B. Your A square is nothing, but it can be written as mod of A square or equals to mod of A times A. You can break it as mod A times mod A, and then you can square it. Which of the following is equals to A squared over mod of A? So they basically want us to simplify our options 1, 2, and 3 to get to the question. But this is what we know. So we need to find the possible values of A square over mod A, and A is not equals to 0. Now, since we know that A square can be written as mod of A squared, and why are we writing that? Because we see mod of A cannot be written as A. It can be minus A also. because they said a is not equal to 0. So a can be greater than 0, a can be less than 0. So the only possible ways we have right now here is to convert the numerator. So a square can be written as mod a square. I can cancel out those mod a. So I left out with just one mod a. So they are just asking us that which of the following after simplification can give me mod a. Of course, the option number one says the same thing. Now let's talk about the option number two. Mod of a square is a. A over a is only a. But we cannot say whether mod a would be equals to a or not. It could be minus a also for less than 0. So that is not correct. Option number third says almost the same thing, mod a over a square. It's 1 over mod a. So mod a cannot be equals to 1 over mod a for all the values. So there is only one option that is correct, and that is option number 1. A is the correct answer for this. Now this is very good question, which says that if x is less than 0, that means x is already negative. Then we're dealing with a cube root sign. We're dealing with one mod, and then we're dealing with x with the even power. So we'll apply all the possible cases that we have learned so far. The seventh rule is we know that mod AB, how to break up. The first rule was nth root, even n power, its modulus, odd n power is the same number. But how do we break it? Because we have a modulus x and then x square, that's under a radical sign of cube root. And then we have a first property. So this all our applications has to be done. Now let's talk about the two types of absolute value inequalities. Type 1 says that if your p is greater than 0, your modulus of px minus q is less than equals to r. So if we see such kind of expression where it says p is greater than 0 and then the modulus of px minus q, some q, is less than equals to some r, then this particular inequality, which is less than equal to or less than, is always in between. So how do we actually break it or write it as minus r is less than equals to px minus q, which is less than equals to r. That means px minus q becomes the range between minus r and positive r on the number line. We could add up q on both the sides to remove q from the center. So we are left out like q minus r is less than equals to px, which is less than equals to q plus r. Divide both the sides by p, we're just left with x. So that becomes q minus r over p, q plus r over p. Now, since p is already greater than 0, we are dividing by a positive number, so inequality will not flip. And the second condition says if p is greater than 0 still, it's a positive. And if we have something like px minus some q getting minus, and it is greater than equals to r. If it is greater than equals to r, then we hold with two inequalities. Px minus q would be less than equals to minus r, and px minus q would be greater than equals to r. So this is the example for type number 1, which says 2x minus 1 is less than 3. It is less than, so we'll write it into the between. So it becomes minus 3 is less than 2x minus 1, which is less than 3. Adding up 1 on the both side, we get minus 2 is less than 2x, which is less than 4. Dividing by 2 on both the sides, it gets minus 1 is less than x, which is less than 2. So that means value for my variable x lies between minus 1 and 2. This is for the type number 2, which says 2x minus 1 is greater than 3. That means 2x minus 1 has to be less than minus 3, and 3 has to be less than 2x minus 1. Solving for both, I'll get the values for x. So let's solve this question, which says 3x minus 4.5 is less than 1.5. Now this is less than. We have type number 1, we have type number 2. We remember it. So now we know that it's a between condition. So minus 1.5 would be less than 3x minus 4.5, which is less than 1.5. Adding up 4.5 on both the sides gets me 3 is less than 3x, which is less than 6. Or you could say 1. If I divide both the sides by 3, I get 1 is less than x, which is less than 2. Now we have been asked which of the following can be the value of x. The value lies between 1 and 2, which is 4 over 3. D is the correct answer. This is also frequent appearing format or a concept, distance between x and y on the number line. So distance between x and y on the number line, either it could be modulus of x minus y, or it could be modulus of y minus x. So 2 minus of minus 1. See, we're dealing with distance. So there's nothing called a negative. So if this is a question, modulus of a minus b minus modulus of minus a plus b is what? Now we know that modulus of x minus y or y minus x is one and the same thing. We are actually finding the distance between 2 points. Now a minus b can be written as b minus a. So minus a plus b is nothing, it's a b minus a. So a minus b minus a. It's one and the same thing. The distance is 0. It's a commutative because it's absolute value. Subtraction is not commutative, but since it's absolute value, it will be commutative. Now we have a question, is p minus q is less than p minus r? There are 3 variables involved into it. It's not q minus p. So if we try to modify, they will not get much out of it. So, and we have both side, modulus. So right now we're dealing with 3 variables, p, q, r. We need 3 equations. Answer should be E. So we'll combine both the conditions. Condition number 1 says that modulus of q is less than modulus of r. If I subtract 0 from both the side, it becomes q minus 0 is less than r minus 0. That means distance between q and 0 is less than distance between r and 0. And p is already greater than 0. Now let's say if q minus 0 is less than r minus 0 over here, and p is already greater than 0, so p is already greater than 0. So distance between p and r is shown here in the diagram, which is modulus p minus r. So if we are taking the points as r, p, q, then the distance of p minus r is greater than distance of p minus q. But if you're taking a distance as qpr here, then the distance of p minus q would be greater than distance of p minus r. You can take an example for putting in values also. If r is equals to minus 10, p is 1 and q is 5, then q is more closer to p. But if q is equals to minus 5, p is 8 and r is 10, r is closer to p. So the answer would be E. That is what we already got at the start when we had matching up of variables. So I'll again repeat the same thing that, for absolute value, to get on to the absolute value, I'll request go through all the concepts of inequalities first from the last webinar. Once you're done with it, go through all the properties and the frequent cases that I have covered today, the 7 major cases. Go with every single logic. Don't cram them. Have logically connected, because if you cram, you won't be able to apply it. And just looking at those, that if this is less than a, then it happens to be square. Don't say to yourself, yeah, that is practically possible or that will always happen. No, it's not always about to know the concept. It's about the application, how quickly you are able to apply, and where you would be able to apply those 7 cases, right? I'm telling it to you, you know see, in an hour's time or in 70 minutes, I understand that I have to keep a pace. There would still be some questions, still be some doubts to the questions. How did we apply? We are more than happy to assist you. We welcome your all the doubts. But understand that there exists some approaches or quick techniques which can help you solve the questions quickly. And GMAT never asks you to sit for 4 hours to solve. So definitely there exists something which can save your time and boost your accuracy. And for, of course, that is not the conventional approach. It's not bragging things, but it is fact. Because I myself solved a lot of questions first by the conventional approach, and then I solved through the variable approach or the IV approach, and I see the difference. The start of the question comprehension is almost same, but once you take the conventional route, it ends up with a lot of variables and unknown quantities. With the conventional approach, you will always face that problem. With variable approach, you know what has to be done. If it is E, then combine and let's go with it. If it's C, combine and go with it. Same goes for IV approach as well. So these are some math revolution contribution to the success journey of all the students. And how do we mark it? As now we have a solution pack, so we have a trial pack. This is a very common pack that most of the students would often take, go through the lessons. And the best part is when they sign up for the trial pack, they often get convert. It's not about a convert, but they wish to continue to learn those approaches because they find it unique and time saving, and they often end up taking a long course with us. Anyone who is very close to 48, 49 is still struggling to make it 50, 51 can go for a shortcut 1 month package. Anyone who is about to start the GMAT journey, best of luck for to those people, and they could start with either of the package from 139 to 199. If you feel like your approaches are, you'll know the approaches, but how could someone assure you that you're applying it right? You should often go for a private tutoring, so you can check out the experts and validates. And you know anyone who wants to talk to me directly over the call can book a live consultation call, which is free, directly from a GMAT website, GMAT club website, or it's there on the Math Revolution tab also. If you have any question, any doubt, just write me on info@mathrevolution.com regarding any package or services. If you have a questions regarding any topic, webinar, math, anything, just write me on my email, which is puneet@mathrevolution.com. Go for a free resources. You still have a time to master variable approach. So learn it completely. And with the same, let's connect back next Sunday for a new webinar. I'll thank you so much for your time. You have a great day ahead. And please do go back to the webinar once they're uploaded. This will be uploaded in a short while. Inequalities is already there. You can leave the comments there. You can write me in the email. And one more thing, once you press the like or the dislike button there, you automatically gets the update on it. So don't forget to either like or dislike. Okay. Okay. Thank you so much. With the same words, I take a leave, and you also have a God bless. Thank you. Bye bye.